Okay, so we do know that we have starch, we are reducing sugar, non-reducing sugar. We're going to test for the protein, we're going to test for the lipids. So what are the reagent used, or what are the procedure, and what are the observation, whether positive and also the negative results? Okay, so first we look at the starch. So for starch, very simple. Okay, very simple. We take 2 drops of the starch and then we place it on a spotting towel. Spotting towel basically is something like a towel, a quite thick one with the groove. So it means that got something like a well for us to drop. So we drop 2 drops of the sample and then we add 2 drops. Highlight, guys, it must be iodine solutions, or you claim it as iodine in potassium iodide solution. Are you clear? Here is iodine in potassium iodide solutions. Okay, so we do know that if starch present, then the yellow-brown color of the iodine solution will turn into blue-black. Okay, but if a negative means the absence of the starch, then you're going to get the same color as iodine solution, which is yellow-brown. Okay. So the test for the reducing sugar. So what are the reducing sugar that we have? The test for reducing sugar, we have the glucose. We do have the fructose. Okay, galactose. Those are monosaccharide. Disaccharides, we do have the maltose. We do have the lactose. So we're going to learn in detail why they have the reducing property. Okay, so very simple. So we're going to add 1 cm cube of the sample to the test tube, and we add another cm cube. Highlight the reagents here. It's called Benedict solutions or Benedict reagent. Okay, so when we add already, we mix the solution well. Okay, imagine now you add 1 cm cube of the sample, then we add another 1 cm cube of the Benedict solutions. We mix them well, and highlight, you must place them in boiling water bath. If water bath alone not enough, or at least tell me water bath that have a temperature more than 95 degrees Celsius, then it's accepted. Okay, either you say place the test tube in the boiling water bath, or you place the test tube in the water bath at 95 degrees Celsius for how long? For 3 minutes, and you observe the color change. If reducing sugar present, then you can see that the mixture start to turn from the blue color into the green. Okay, it depends on concentration of the reducing sugar. If the reducing sugar concentration is high, you can see that it turned from green to yellow to orange and to red. Are you clear? Or sometimes it can go up to brick red. Are you clear? Okay, so the principle behind how this thing happens, I will teach you guys when we go to the lab. Are you clear? Okay, I will do the briefing before, then we will be able to see how the change in the color actually take place. Okay, so as long as you can get green, yellow, orange, red, or brick red, so means that reducing sugar is present. But if let's say no reducing sugar present, so or absent of reducing sugar, the mixture remains as blue color. Okay, now non-reducing sugar. Non-reducing sugar here, if you want to carry out, actually we don't have a specific test, a very, very specific test to check for non-reducing sugar. So in our syllabus, non-reducing sugar only one, which is sucrose. Okay, so how we can do this? First, we're going to carry out the reducing sugar test first. Okay, now if your sample only contains sucrose, so because sucrose is a non-reducing sugar, so basically when you heat it, you repeat the same step like this. Okay, you repeat the same step. What you're going to get here is you're going to get blue at first. So this is, we say that before hydrolysis. Can I say that? Before hydrolysis, it should stay as blue color. So we get a fresh sample again. But this time, we don't straight away run the reducing sugar test. We're going to use a diluted hydrochloric acid. So we add 1 cm cube of sample and 1 cm cube of diluted hydrochloric acid. So why diluted? Because dilute here will provide the water molecule for hydrolysis to take place, and hydrochloric acid will act as the catalyst. Okay, so this catalyst is going to break down the sucrose into what? Into the glucose and fructose. Okay, so therefore glucose and fructose, they are reducing sugar. So for non-reducing sugar test, actually we are not testing the non-reducing sugar, but we detect what? We detect the reducing sugar. Okay, so what we're going to do here is we add 1 cm³ of sample to 1 cm³ of diluted hydrochloric acid. We make the solution well and place the test tube in a boiling water bath again for 3 minutes. So this one actually is for the hydrolysis, to break down the sucrose into the glucose and fructose. Okay, and then we're going to cool down, okay, the temperature of the, because we inside the boiling water bath, right? So we cool it down by shaking it under running tap water. And after that, we're going to add this sodium bicarbonate. So this sodium bicarbonate, the function is to neutralize the acid, because Bendix's reagent work the best in alkaline solution. So therefore, with the presence of acid, we won't be able to get the result. So what we need to do here is we need to add sodium bicarbonate. And because the reaction between the sodium bicarbonate with the acid release the CO2, we will be able to see the bubble. So it means that when you add, you can see the bubble. So it means that I haven't finished the neutralization yet. But if you continue to add this sodium bicarbonate bit by bit, you go and scoop it out, the whole scoop, and then the spatula, the whole scoop, and then you add it in, okay? Then you don't have this, you have the problem, okay? So what we do here is we add bit by bit here until you won't see any bubble. So it means that neutralization already complete. You will see a little bit of precipitate, okay? A little bit of precipitate. So this, a little bit of precipitate here basically indicates that the neutralization has been completed, okay? Then after that, what we're going to do here is we add 1 cm³ of Benedict solutions, and then again put them into the boiling water bath for 3 minutes. So when you do like this, basically if sucrose present or non-reducing sugar present, because hydrolysis we're going to produce a reducing sugar, I will be able to see the color change. So what type of color change? So it starts from the blue, go to the green, slowly go to the yellow, orange, and red. If the concentration is high enough, you will be able to get a breakthrough rate. Okay, so but this one is after hydrolysis, after the second reducing sugar test, which is after hydrolysis. But if the mixture, okay, or the what we call this the sample, if the sample does not contain sucrose or non-reducing sugar, basically after the first and second reducing sugar test, the blue color remain as blue. Are you clear? Okay, any questions so far? Can you visualize it? Okay, so now next for protein. So for protein, we are going to use the Biuret reagents. Biuret reagent. Now, for Biuret reagents consists of 2 reagents. It's not one chemical, but 2 chemicals. So what we're going to do here is we add 1 cm³ of the sample to one of the test tube, and you add 1 cm³ of 10% KOH, sodium hydroxide solutions. Potassium hydroxide. Sodium hydroxide also can, okay? So you can either use this sodium hydroxide or potassium hydroxide solutions, and you mix the content. So you add 1 cm³ and 1 cm³ in the test tube, you shake it, you mix it. Okay, and then you use a pasture pipette to start to add this 0.5% copper sulfate solution, which is blue color, very, very light blue color. You drop it drop by drop, okay, but do not exceed 10 drops. If you use 0.5, do not exceed 10 drops. Okay, why? Because more than 10 drops, you may have the false result. Okay, so means that it's not protein anymore. If a protein less than 10 drops, you will be able to see the color change. So what is the color change? So if from the light blue, this light blue because of the copper sulfate solution, the light blue. So this light blue will change into purple. Are you clear? Will change into the purple. If a negative means that no proteins, then it will remain as light blue. Okay, it will remain as light blue. Are you clear so far? Okay, the light blue actually is the color of the copper sulfate solutions. And the last one, if you test for the lipids, very simple. We add 2 drops of the sample into the test tube, and our reagents here is not a special reagent, it's just ethanol and distilled water. So what we're going to do here is we take the ethanol, 2 cm of ethanol. Okay, we use the ethanol to dissolve any sample that contains the oils, okay, or lipids, and then we mix it with distilled water. So what will happen here is they will form these suspensions, a milky cloudy suspensions known as emulsion. Okay, so this emulsion basically is something like this. You got this suspension, something like a powder, something like this. So if you place a piece of paper with the wording behind the test tube, you won't be able to read the contents. Okay? You won't be able to read the contents. So this one, consider that. Okay, it show that lipids actually present. But if let's say no lipids, so the mixture remain clear and colorless, you will be able to read the words through the test tube. Okay, so with this, I have done the general procedure and also the observation, positive and negative observations. Are you clear? Okay, so stop recording. Now, let us take this reducing sugar test as our example. Reducing sugar test. Now, I won't go into the very detail of the principle of the reducing sugar test, okay, because we're going to do this in the practical. So for reducing sugar test, generally, we do know that if reducing sugar present, then you can see that it will change the color from blue to green, green to yellow, yellow to orange, orange to red. This is the color scheme, okay? Any other color scheme beside this going to be counted as the correct color. Are you clear? So therefore, you have to make sure that you describe it correctly. So if you have the red, green, yellow, orange, and red, so we say that this one reducing sugar present. Okay, if you get the blue color like this, so means that no reducing sugar present or absent of the reducing sugar. Are you clear? Okay, so now, in this process, if you want to compare, okay, in this case, our result here is called qualitative result. Now, what's the qualitative result? So it means that we only read the color. Are you clear? We only read the color. So generally means that I can say, oh, I saw it as the yellow color. You also see it as a yellow color. Okay, many people also see it as a yellow color. Okay, I do my experiment, you do your experiment, you see yellow. But how you sure that your yellow and my yellow, they are the same shade of yellow? Or you see the orange, I say that it's orange. Are they the same intensity of the orange or not? We do have the problem here because our result is the qualitative data. Qualitative means, oh, got color, observation, no measurement. Okay, so one of the criteria here was a qualitative result means no measurement. Are you clear? When it's no measurements, so means that we do have this, the objective in this case, okay? I can see it as, okay, different people will have a different perspective or different judgment in terms of the color, okay, in terms of intensity. So we want to change our reading from qualitative reading to quantitative reading. So what's being quantitative? Means that something that you can measure. So what we can measure? We can measure the color intensity. Then you don't need to argue, hey, my yellow is higher intensity. Your yellow is not so high intensity, or lower intensity. Okay, so we can use these machines or instruments known as colorimeter. Be careful your spelling, guys. It's a color, not calo. Okay, it's not the calorie meter that we use to measure how much calorie you eat. Okay, the food that you eat. Okay, one day. So this one is called as a colorimeter. Colorimeter won't tell us what is the color. Okay, you don't put the tube in, oh, this is red color, or you put it, oh, this is brown, this is whatever color. No, they won't tell you the color, but they will tell you the color intensity. Let's say tell you, oh, this one is 4%, oh, this one is 5%, okay, this one is 10%. So it tell you a value. It colors the intensity in value. So that's why we do have the measurement. So you don't need to argue, oh, your yellow and my yellow, are they the same? Or maybe my one's, okay, when I read it, using this colorimeter that determine the color intensity for us. So my one, okay, let's say, for example, they give me 55%. Oh, your one's 56. Oh, yours one intensity higher compared to mine. Okay, so this is one. Okay, now, second, or we can measure the mass of precipitate. Now, what's this mean? Okay, if you look at the reaction here, why we call those sugar as reducing sugar? Then we have to look at a little bit of principle. I won't go into detail as I say that. So for Benedict reagent, it's blue color because it contains Cu2 plus ions, copper 2 ions. So in the reactions with the presence of reducing sugar, Cu2 plus will be reduced. Okay, with the presence of the reducing sugar. So this reducing sugar will have the ability to reduce the Cu2 plus, which is in aqueous phase, into Cu plus or copper 1 ions, which is solid. And this solid is red-brown or brown precipitate. Red or brown precipitate. Are you clear? So it means that the higher the concentrations of the reagent sugar, I will be able to get more brown precipitates. I will be able actually to measure the dry mass of precipitate. Are you clear? So what we're going to do here is we use a filter paper, we filter out, okay, we collect these precipitates and we dry them in the ovens and then we actually measure. So the higher the mass of the precipitate means that the number of reducing sugar will be higher, or the concentration of the reducing sugar is higher. Are you clear? Clear? So basically, the higher the color intensity, or the higher this the precipitate, mass of the precipitate, then I can claim that the higher the concentrations of the reducing sugar. Common sense, right? Understand? Right? It makes sense, right? In this case, but I have the big buts here. If you want to compare in this case, when you involve the elements of compare, let's say I have sample A, sample B. Okay, I have sample A and sample B. So if I want to know which one having higher concentration of, let's say, reducing sugar, okay, which one's sweeter, I mean, we don't want to test it, taste it, we don't want to taste it. using my tongue to know which one is sweeter, I can use the Benedict solution to help me to check. But provided that in this case, if you want to do a compare, then you have to be careful. You cannot use 1 cm cube of Benedict reagent plus 1 cm cube of sample, like what we have discussed previously. Are you clear? If you want to compare, this one is for us to know whether yes or no. Okay, if you use 1 cm cube of Benedict reagents with 1 cm cube of sample, we only will know, oh yes, I can see color change. Basically, I can conclude reducing sugar present, full stop. How much reducing sugar present, whether A more than B or B more than A, you won't be able to know. Are you clear? Okay, by this test. Okay, so why? Because in this case, you are not sure whether all reducing sugar have been reacted or not. Okay, let me show you guys one of the example here. Let's say this is A, sample A, and sample B. Okay, sample A, let's say, contain 200 reducing sugar. Sample B double up 400 reducing sugar, let's say. Okay, so sample A, if I put it 200 Benedict reagent, sample B also 200 Benedict reagent, what will happen here is if 1-to-1 reactions, so this 200 reducing sugar react with 200 Benedict reagent, it gives us the color, let's say red. Are you clear? And in this, okay, I only have 200 reducing sugar that can react because the 200 have no one to react with. I also will get red. So can I claim that both of them have same concentration? You can't actually claim that both of them have the same concentration, because in this case, you still have another 200 reducing sugar that have not reacted. So in order to make sure that all reducing sugar have been reacted, then you have to increase the Benedict reagent. So in this case, if you anything to compare, you want to compare, right? As long as involve the element of compare, then Benedict reagents must be in excess. Mean you need to use more. Are you clear? You have to make sure that the Benedict reagent must be in excess. So now, how many of you actually have this question? Why the precipitate is a red color? Why this red color give us a different, how it can turn into the green, how it can turn into the yellow, how it can turn to the orange? Actually, if you look at this process, okay, so we have green to yellow to orange to red. So it depends on what? It depends on the precipitate. So if my Benedict reagent in excess, so means that not all Cu2 plus reacted. But I know that all reducing sugar reacted. Correct or not? Are you clear? If the Benedict reagent in excess, so means that not all Cu2 plus reacted. Correct or not? Because we have more Cu2 plus. But our reducing sugars, all of them will be reacted. So look at this. It's a mixture between the precipitate and also the remaining Benedict reagent. Precipitate will be red color. This Benedict reagent will be blue. So this is the solid. This is the liquid form or aqueous form, sorry. Solution. So the interaction between these solids and the aqueous will give us the different color. For example, let's say if I have 20 Benedict, red precipitates and the remaining 80 of the Cu2 plus, this combination maybe give us a green color. Correct or not? If I have hundreds molecule, hundreds benedict reagent, okay, so 20 reacted to form precipitates, and remaining 80 that non-reacted, it will give us the mixture of this red precipitate and the blue color will give us a green, okay, a bit greenish color. Okay, if let's say out of 100 benedict reagent, 80 red, okay, precipitate form, 20 only blue, this one may give us orange. Can you see that? So no matter how, you have to make sure that your benedict reagent must be in excess to provide the blue color shades that interact with this precipitate red color, give us a different degree of the color. Are you clear? Okay, so therefore I will be able to know which one having higher concentration, which one having lower concentration based on the intensity of the color and also the mass of the precipitate. So term and conditions, benedict reagent must be in excess. Are you clear so far, guys? Okay or not? Clear or not? Okay, if you're clear, then let us look at this. Okay, whatever we discussed just now will only involve a pure sample. What's in pure sample? Either contain glucose, okay, or sucrose. Correct or not? If my mixture contains glucose and sucrose, how we know? Okay, so we are going to compare before hydrolysis. So before hydrolysis, before we add the HCl solutions, then we carry out the reducing sugar test. So before hydrolysis, who will respond? Glucose will respond. So if my benedict reagent in excess, in this case, only glucose respond, yes, I may see a color change to yellow. Okay, let's say I have 10 glucose and 10 sucrose. So only this 10 glucose will react. So with the benedict reagent, give us yellow color before hydrolysis. Okay, and then after hydrolysis, what will happen after hydrolysis? Because after hydrolysis, glucose won't carry out any hydrolysis, cannot. So in the reducing sugar test, after hydrolysis, so this 10 molecule of glucose, just now during hydrolysis, what they do? They do nothing, they're swimming inside, okay? So this 10 glucose is still there. But this 10 sucrose now is hydrolyzed into 10 glucose and 10 fructose. And all of them, they are reducing sugar, correct or not? So means that the color intensity, now you can see 10, 10, 10, 30 of them react. So the color intensity maybe go to red color. So that's why we need to make sure that our benedict reagent in excess. If the benedict reagent is not in excess, what will happen? You may get yellow, then the rest also yellow. Why? Because not enough benedict reagents. Are you clear? Okay, so in this case, you can see that there is increase in terms of intensity. Then I can conclude, oh, got glucose and sucrose. If only glucose, then first time yellow, second time, also 10 molecule, right? So means that also give us yellow. If sucrose only, easier. First one, no reaction, so blue. Second one, give me the color, let's say orange color. Are you clear? So this is how you differentiate whether got glucose only or sucrose only, or a mixture of glucose and sucrose. Are you clear? Okay or not so far, guys? Okay, or if I don't want to read the color, I can use a colorimeter to, the colorimeter to read the color intensity. Or I can use the, my lab is poor. Let's say, for example, I don't have money to buy the colorimeter, the colorimeter, the color one, okay? Then I can always measure the mass, okay, of the precipitate. Then you can see that there is an increase in the mass of the precipitate to indicate that there is a presence of the non-reducing sugar. Okay, so with this, I've done for today's class. I stop the recording.